So we've been throwing this word around quite a bit: system, software, operating system. They do mean the same thing. Let's take a look at what this actually does and how it works. So system software, we already defined this, also called OS, operating system. It's a special type of software that directly manages the hardware and software resources, which is kind of confusing, right? Because system software is software itself. How is it managing the software? It's software that manages software. Well, it turns out it's the middleman between the application software and the hardware beneath it. So it makes sure that everything works smoothly. So it manages all the hardware parts of the computer, such as power consumption. It could be the fan, it could be the power going to the screen, the monitors, the input output devices. And it makes it easier for that high layer, right, of application software to say, hey, I don't care which computer I'm running on, the OS is going to handle all those really complicated parts that deal with the hardware. So that's why software, you can download it onto pretty much any computer. The reason that it works on all sorts of computers is because there's a special operating system that knows how to translate all the complicated hardware stuff up to the application software. So Facebook doesn't have to worry about, which computer am I running on. The OS will handle that. It'll be the middleman between the two. So here's the software stack. So the different layers of a computer system. So we have application at the top, the application software. So it could be Photoshop, it could be, some kind of media player, it could be Zoom, it could be Spotify. So that's at the very top. It of course provides instructions to the computer, but every computer has different hardware. Imagine having to transform those instructions to fit every single different type of hardware. There's so many different brands of computers, different specs on that hardware. Having that application software have to handle all that stuff would be a mess. Me as a software developer that created application software, I didn't want to worry about which device it was running on. I just wanted to make the application work. So that's where the OS comes in. It says, hey, application software, all the complex things like power consumption, screens, fans, processing, switching between tasks for the CPU, using memory, I will take care of that. I know my computer. I know the rules of this computer. I know the limitations. I'm going to take care of that stuff. So all you have to do is give me the basic instructions like edit a photo, write a document, etc. And at the very bottom, we have the hardware. Of course, the lowest layer, right? So that's why the OS is the middleman. It helps the application software talk to the hardware without actually directly talking to it. There are other layers: middleware, hypervisor, firmware, but at a high level, we're just going to focus about application software, OS, and hardware at the bottom. So some of the differences between system and application software. Remember, system software, it's the DNA. It's installed when you buy the computer, usually by the manufacturer, runs whenever the computer's on. In fact, it'll run in the background, as we'll see in some of the next slides. So you don't really have to worry about what it does. System software does its own thing and makes sure that the computer is running smoothly and doesn't blow up. And if you notice, the language of system software is low level. Application software is high level languages. Some that you maybe have heard about if you know a little bit about programming: Python, Java, JavaScript. Those are all high level languages. We use high level languages to write the high level layer of application software. So yeah, this will be software that meets very specific tasks. There's software for pretty much everything these days, right? For video games, that's an example of software. Very specific purpose is to have fun. So usually you install this software. It doesn't always run right. It's only running when you directly tell it to run. And of course, the computer doesn't need it. It's not a critical software. It might be critical to you, but the computer, will run fine without it. Without system software, that computer is going to be a pile of metal. It won't know what to do. So there are different types of operating systems. There's personal operating systems for PCs, server operating systems for server computers, mobile operating systems for mobile devices, and embedded operating systems for embedded computers. If you're taking the quiz, be very careful for which type of operating system I am asking for. If I say personal operating system, I'm talking about computers. If I say mobile operating system, I should be talking about smartphones. A little clue for the quiz. So PC operating systems. These are your actual computers, your laptops, your desktops. It turns out Windows OS by far globally is the most popular operating system for computers. 72% of PCs. Windows 1.0 was released way back then. I think it was in the 80s, but it wasn't popular due to competition from Apple's Macintosh. So they've always been neck and neck, Apple and Windows, or I should say Apple and Microsoft. The reason it's called Windows is because a window, right, is all those little boxes on the screen that represent a different app running on your computer. So Windows, and even the logo is actually just a window if you've never noticed. Apple Mac OS, that's used by 15% of PCs globally. It was the first commercially available GUI-based operating system. So GUI stands for Graphical User Interface. It's the first OS for PCs that had icons, pictures, images, which of course, as we know, is way easier to use, right, than just typing in commands. The reason it's called Mac or Macintosh, it's a reference to a variety of Apple, which is just known for crispness and flavor. One of the founding team members of Apple, decided to go with Macintosh. So Mac and Apple are known for their strong design and focus on graphics. Definitely competitive with Windows. Some people prefer Windows. Some people prefer Mac. This will be up for debate actually in this week's discussion, where you'll decide what's the best operating system and you'll have to defend why it's the best. There are other operating systems besides Windows and Apple. There's Linux, HP, IBM. A lot of these other ones are actually just different flavors of Linux. So if you take my Linux class, we do actually use Ubuntu on our computers. We run them through virtual machines. So basically, we have our computer have a baby computer and run a smaller computer in there. So yeah, all different types of operating systems. Oracle is another one. So yeah, Windows, of course, the most popular. Apple second best, but there are different ones depending on what you're using the computer for. Linux, very popular for engineering, for really specialized high tech uses of computers. Of course, operating systems we should all be familiar with are mobile operating systems. Most of us in the US probably have Apple, but globally it turns out Android is by far the most popular. Globally, 70% of smartphones are running on Android operating system. It was founded in 2003 and acquired by Google in 2005. The first Android smartphone didn't come out until 2008 with the HTC Dream. Google Play Store, which is the place where you can publish and purchase apps or install them. They're not all for costs. A lot of them are free. Was released in 2008. Just a few months later, Apple came out with the Apple App Store. So that's what makes these computers so great, is that they have a rich support for application software. So of course we're discussing operating systems right now, right? But the reason these OSs, these types of devices became so popular is because you can download an application software to do pretty much whatever you want. And these operating systems make sure that they work well with the variety of phones, right? Whether it's an HTC phone or in a Samsung phone or a Google phone, they're all running the Android operating system to make sure that whatever parts you're running on, whatever hardware you got, that application software is going to run smoothly. So Apple has iOS, which is used by 28% of smartphones globally. It was introduced with the original iPhone, the iPhone OS in 2007. So of course, showed into iOS eventually. So it introduced the App Store also in 2008, which again was a big deal. It gave you access, right, to all sorts of custom apps to solve all custom types of problems, right, that you might encounter with the phone. iOS 5 was the first time that we had a voice activated assistant. So that was part of the operating system, right? Saying, hey, now I'm going to give you voice data and you have to translate that into information for the user. And then OS and hardware. So remember, the job of the OS is to translate the user input down to the hardware, application software down to hardware. OS sits in the middle. So there are several layers that ultimately convert that input into binary code. Remember, binary is that low level. It's what the hardware understands. It doesn't understand anything but zeros and ones. Well, it turns out the OS, in order to get things to work correctly, it is running a lot of stuff in the background. We call these startup programs. I like to compare this to the human body. There are a lot of things that we do intentionally. When I pick up this can of soda, right? I had to think about that process. But there are other processes in the human body that I don't have to think about, such as my breathing, my blood circulation, my digestion. That is already happening automatically. That's the same with computers. Computers have this intentional part, which is the application software, but it also has this autonomous part, which is the operating system. Operating system makes sure that everything in the computer runs smoothly and things don't blow up. Just like with my autonomous nervous system, right? The parts of my body that make sure I don't, you know, give up and die. So computers work very, very similarly to that. So these manage things like display, file systems, security services. Hugely important, right? Is security to make sure that people can't just type in a random password and get into your computer. So a lot of these processes run in the background. So they support the system without actually getting in the way of what the user is trying to do. So you'll never see these programs. Of course, they are taking up resources. So this is the task manager, which if you're on Windows, you can run this very easily. Kind of an old legacy command is Control Alt Delete. And then I have a menu up here. You can't see it because it's on my other screen, but here's the task manager. So it's showing me everything that's running on my computer. So I have 6 apps running. I have Google, that's where the slides are at. I have OBS, that's what's recording my screen. I have Spotify because, of course, I like to listen to music. I have Zoom meetings open because that's how I'm able to do the recording with the transparent background. So I'm combining two softwares to achieve this video. And then I have 88 background processes. So I didn't start any of these. These were all started automatically by the computer. If I try to stop some of these processes, it could be catastrophic for the computer. It could crash the computer. So I don't want to end any of these. So if I end, for example, my Spotify application, nothing's going to happen to the computer. I'm going to do end task. Computer's just fine. If I go down to one of these backgrounds or one of these window processes, something unintended might happen. So these are the kind of processes that are automatic in making sure that your computer is running smoothly. And as you can see, there are a lot of them that start up. And again, these run in the background automatically. The user does not interact with them or start them up. It's all the operating system. They're the ones deciding which background processes you need. And then these apps right here, these represent the application software that I am running as a user. So let's go ahead and return to the slides, to Google Chrome. And you can see here the screenshots, right? This is the task manager's tool showing the running programs and processes. So check out this video of an early operating system. So this is what it looked like way back then. Here on the right, the image is actually someone who figured out how to put a ChatGPT client on the DOS operating system. So one of the original Microsoft operating systems. So command line, somehow they figured out to get the two to work together. So kind of a cool picture there. But here, this video, if you click on the icon there, just a little bit of the history of operating systems. Definitely encourage you to watch it just so you can see, the trajectory of how we started to where we're at now. So what's created by Microsoft is really early operating system, and it had a command line interface. So you had to type in commands, no GUI. So no pictures, no icons, no buttons, terrible UI. I hated command line when I was first learning it because it's intimidating, right? You're supposed to just know commands, where as if I hop into a random computer that has a GUI, I'll see buttons, icons, pictures that will kind of like give me hints, right, on where to click, on what to do to get the computer to work. So of course, even though it's obsolete now, it definitely laid the groundwork for future operating systems like the Windows operating system of today.